This is the last problem from chapter 10. It is for the confidence interval of two population proportions. And the parameter of interest is the difference in the two population proportions, P sub 1 minus P sub 2. We are looking at the same example as in the hypothesis testing case. We have two call centers, one in Mumbai and one in Manila. And we want to see the proportion of calls answered within 20 seconds in Mumbai, P sub 1, minus the same proportion P sub 2 for Manila. And we want to set up a 97% confidence interval for that difference. And here is the formula. So first let us set up the sample summaries. We want the sample sizes, the number of S calls, and then the sample proportions P bar sub 1 and P bar sub 2. So we have count Mumbai, and the columns are already named. And then we have count Manila, and those are the two sample sizes. The number of S calls will be count if Mumbai, then within quotation marks less than or equal to 20. So that will count all the calls with less than or equal to 20 seconds of call answer time. Then same count if for Manila, comma, quotation mark, less than or equal to 20. Okay, now the sample proportions are the number of S calls divided by the sample size. Okay, copy that and format. So that gives us the P bar sub 1 and P bar sub 2. Now from this we can now set up the standard error for P bar sub 1 and P bar sub 2, and since this is kind of a long formula, let us split it up into two parts and then put them together. So the first part is P bar sub 1 minus P bar sub 1 over N sub 1. So that is P bar sub 1 times 1 minus P bar sub 1 divided by the sample size. Format, and we'll copy that to the next column. So now we have that and that setups. Now we'll put the two together in square root, and that will give us the standard error. So that's the standard error for P bar sub 1 minus P bar sub 2. Now we want 97% confidence interval, and that is 1 minus alpha. So alpha is 1 minus that. The z table value is given by norm.s.inv function, and that function requires the cumulative probability for the top tail. So the top tail is alpha over 2, so the cumulative probability for the top tail is 1 minus alpha over 2. So that is alpha, so 1 minus alpha over 2 will give us the lookup value for the norm.s.inv function. So select that function, and that's the cumulative probability, which is the lookup probability, and that gives us the t-table value. The margin of error is the z-table value times the standard error that we just computed a couple of minutes ago. So z times the standard error gives us the margin of error. Now we need P bar sub 1 plus minus P bar sub 2, the first part. So here is P bar sub 1 minus P bar sub 2. So that's our point estimate. So that minus the margin of error gives you the lower limit, and that plus the margin of error gives you the upper limit, because if we format these cells, you will get the answer. So that's our confidence interval. So interpretation is we are 97% confident that the difference in the population proportion of calls answered within 20 seconds for the Mumbai and Manila call centers will be between minus 20.4% and 1.2%. So in other words, our justify the text. In other words, the point estimate for the difference in proportion is minus 10% with the margin of error of about 1%, 1.08%.